Hello all and welcome to your last chapter that you're going to see things in for Intro to Calculus. We're going to look at a few ideas from chapter 9, not a ton obviously since we only have 4 weeks left of school. Please be on the lookout in your email for a description of the last 4 weeks and exactly what that's going to look like. I've built in a lot of time for students to catch up on missing assignments and also corrections before the end of the year on June 3rd. If you have questions about what that's going to look like, please let me know, and please sign up for Zoom if you want to talk in person. Let's get ready for the notes for this week, which are going to be broken up over 2 days from 9.2, and then on Thursday, as you can see in the calendar, you'll have an opportunity to work on any corrections or missing work, building that in as we go. So today, though, we're going to talk about differential equations and slope fields. So a differential equation is just an equation with a derivative. So dy dx is a derivative. This is an equal sign. This is a differential equation. Now, what a slope field is that this is a way to visualize or graph a function if you only know about its derivative. So it's a graph of function given its derivative. Now we've done basic ideas of this, but now we're going to look at more complicated versions. So you can see here a little bit number 2. This is an example of a slope field, meaning that the function's slope is going to be along this line. In this quadrant, it's very steeply positive. Here it's very steeply negative. And we have behaviors going along like that. So the first thing that I want to do is show how we make slope fields and then talk about how we use them. So on the axes provided for number 1, sketch a slope field for the differential equation dy dx is equal to 2 minus y over x. So remember, dy dx, or y prime, is the same thing as the slope at that point. So what you want to do is plot each point. So in this case, we already have the 9 that we're going to use. And then what you want to use is find the slope at that point using y prime or dy dx. And then what you want to do is sketch a segment with that slope. So for example, let's look at this first point here. This would be the point 1, 1. So using our formula, we're like, okay, here's the point 1, 1. If x equals 1 and y equals 1, so at 1, 1, slope is 2 minus y over x, which is 1. So I'm using this equation right here. Here's my y value, here's my x value. And so the slope at that point is 1 over 1, which is 1. So I know that the slope is 1 at that point. So I sketch in a little segment with slope 1 like that. And what I want to do is to do the same thing for each of these. Now you don't need to label the slope. The next point is going to be 1, 2. So all we're doing is going to consider this point here, which is 1, 2. So we're changing the y value. Change the y value here. So then we have 2 minus 2 over 1. So the slope at this point, 1, 2, is 0. 0 over 1, which is 0. So again, go through, sketch in a segment there. Now, one thing that you would hopefully notice is that because the y value is 2, it's going to be 0 in the numerator all the way across. So this segment and this segment all have this pattern. And that's what you'll often see, is that there's some sort of patterns here. So like on this line, these are all the same. They equal 0 all the way on this line together, like that. Next, I'm going to take the point 1, 3. So again, all I'm doing is replacing my y value, in this case with 3. This becomes 2 minus 3, which is negative 1, so the slope is negative 1 at that point. Sketch it in like that. We're going to go through the rest of these points. At 1, 2, the slope would be 2 minus 1 over 2. So then that would be a slope of 1/2. So like that. This would be a slope of 1/3. Negative 1/2 up here, negative 1/3. So you can imagine the behavior is almost like there's a horizontal asymptote right there. Now, how do we use a slope field? So a lot of times the slope field will already have been created and it's our job to do something with it. So sketch the solution curves for the slope field below that satisfy the initial conditions. So the idea is that this is the derivative. We're trying to sketch the function. So there's always that plus c. You're like, okay, I don't know if it's starting up here or if it's starting down here. So this is your initial condition. This is the equivalent of finding out where your plus c is. So I'm going to do A in blue, and I'll do B in green just to tell them apart. So f of 0 is equal to 0. So what that means is that the curve passes through this point here. And when I'm asked to sketch it, I'm going to go just sketching based on the segments that we have. So this is the segment that it's on, 0. And then we can see if we follow this, it would go to here. The next segment, here, steeper and steeper down. And again, it's just a sketch. But on this side, we can see the sketch of f of x would look like that. Here, we're going here. And then maybe it looks like this. So it's like a very uneven parabola. But that would be the sketch if it goes through the origin. Here we are given that it goes to the point negative 1, 1. Now negative 1, 1 is up here. So again, that's the point. The next one it goes to is here. Then it looks like, again, it's coming down on this sort of slant asymptote almost. And then it's going steeper, up, up, up. And this would be the curve if it went through the point negative 1, 1. So in this case, it would look a little bit different depending on what the initial condition would be. The last type of question is about, here's the differential equation, right? dy dx is equal to x squared plus y squared. So which of these slope fields would match? So this is usually about canceling out the ones and crossing out the ones that you're like, okay, well, this one doesn't work. So the first one that I'm going to say, all right, I don't think that this is the correct answer, is I'm going to say that I don't think that A is the correct answer. And the reason that I don't think that this is true is that because no matter, we can see here that for A is that if x is equal to 0, the slope is equal to 0. That's what this behavior here shows. And that wouldn't make sense here, because if y is equal to 0, the slope would equal x squared, right? If y is equal to 0, it would just be x squared. Well, that's not the same thing. So it's like, okay, not going to be A. And this is generally how I solve these types of questions. Here, same thing is true, right? You'll notice that this is true for C as well, and D. So once you notice a weird pattern that can't be true, we want to say then that we're looking for B, which must be the only one that fits. There's a couple other ways. The other thing I can say here is that if I have x squared plus y squared, the slope is always going to be positive. Here there are negative slopes, but we know that if I square two things and add them, I'm only ever going to get positive numbers. So that's another reason I could cancel out both A and C. So you want to use different types of logic here. whichever way, it's all about problem solving and eliminating. If you have questions about slope fields over the next few days or about what the last few weeks of the school year are going to look like, please get in touch.